Hey everybody, this is just me showing as quick as possible, like just the sheer basics on how to tune a Gen 3 LS. And this goes over a bunch of different little topics, stuff that people don't really cover too much. It's all implied that you know already, but this is like my goal is here is just to get somebody who doesn't know much about it. They just maybe know like the car parts and stuff and get them up and going. And yeah, that's pretty much it. So to begin with, we have PCM, ECM. They both pretty much mean the same thing. P is powertrain. E is I think it's engine. Computer module, computer module. Basically, they both do kind of the same thing. PCM controls a little more because PCM is it mentions powertrain, so that mentions that you have to keep in mind that it controls the whole powertrain. So transmission even has a couple sensors in the differential. Some cars do, and then you have the engine, the whole powertrain. ECM is just the engine. Sometimes on other cars they'll refer to it as a ECM, even though it does control the transmission, like a 4L60E in some older cars. Um, but yeah, keep that in mind. The one of the main goals of tuning is just for engine performance. There's also transmission performance, but we're not going to go over that. But the gist here is that these control the engine, and the engine is controlled by everything over here. So all the sensors. There's a lot more sensors in this, but these are your main ones that basically control the fueling. The whole point of most of these sensors is just to control the fueling and keep the engine going. And at this certain RPM, we want this much gas. That's the literal basics of it. So we have the map sensor, which is manifold air pressure. With the map sensor, and typically this is how older cars are run with like TBI and stuff like that. With a map sensor, it's able to calculate exactly how much air is in those cylinders with the stock cam because that's already preset in there. So basically, GM would tune this themselves first, and they would enter in all the values that they would need to in order for the engine to run correctly at all ranges of the RPM. So with manifold air pressure, it's literally just the pressure in the intake, positive or negative pressure, a vacuum or a push. Mass airflow sensor. This is not newer technology because it's old now. This is like because we're talking about Gen 3 here. Mass airflow sensor. It's literally just a sensor that's in the pipe that leads directly to the intake. This is basically the whole point of the sensor is that it's able to sense how much air is coming through that pipe. So if you want to know how it does this, basically there's like a little, I don't remember exactly what it was. There's a little resistor or something like that, and it's able to see how much air is coming by based off how much voltage it needs to keep that resistor at the same temperature. Does that make sense? So as air comes by, it cools off that little resistor or sensor, and once it sees like, oh, okay, we're at 5 volts right now, and it's cooling down this much, that means we have this much air coming by. And the PCM is able to it has those reference tables to where okay, we're getting this number from that sensor, and it's able to say okay, that means we're getting this much air in. And it's also another way, just like the map sensor, just to see how much air is actually in the cylinders right now. Does that make sense? O2 sensors. O2 sensors is like the easy, quick post post way to see how you're burning your fuel, how your computer sees how the engine is burning its fuel. So if it sees that it's running too rich with these sensors, it's able to be like, okay, so typically when we're driving around, on the highway at this many RPM, it's able to say like, oh, we're running a little too rich. And there's typically there's 4 O2 sensors on a car. The ones closest to the I can't remember exactly, but there's short term and then there's long term. The gist of the short term is that it, it it analyzes the changes in the basically the mixture that's coming out of the engine, It analyzes it and it's able to make these changes very quickly to the computer. The PCM sees these sensors and is like, okay, these are the short terms. And the gist with the short terms is that we're able to intake this data and make the changes at this very moment. And then we have long-term data, which at the gist of long-term data is that, okay, so we see that this is constantly happening. It constantly runs lean, when we're driving highway speeds, highway RPM. So that means we need to dial that back. And it learns, you know, and typically, as an engine degrades as it gets older, the emissions do get worse, and that's where the O2 sensors come in. It's like having somebody constantly adjusting the fuel mixture in your engine as time goes on. Let's say your spark plugs don't work as good, you're not burning fuel efficiently, and it's getting out to the tailpipe, which is bad for the emissions and etc. So the O2 sensor is able to detect that and to be like, okay, well, the spark plugs are getting older. Let's go ahead and dial back the fuel when we're running around, stuff like that. You know what I mean? And that's the gist of the O2 sensors. EQ, equivalency ratio. So when you're driving around, your computer is constantly commanding a certain ratio of fuel to air. And let's say you put it to 100% full throttle, and your computer that controls your engine is going to demand a certain air to fuel ratio. And that's super important because that's basically your your final product on what's going to be delivered, what the computer is trying to deliver to the engine. Does that make sense? And then we have Spark. What I mean by Spark is basically like your Spark Advance. And yeah, that's pretty much it. There's not much to that. So the main things is going to be map, mass airflow, and equivalency ratio. Uh, so typically you would start off with your equivalency ratio. Uh, you would set whatever your equivalency ratio for power enrichment, etc. in the PCM. That's all very basic. So basically, what are your goals is what you're going to have to ask yourself when you're setting this stuff up. And then you have your MAF and your map sensors. Both of these just detect basically how much air is in the system at this very moment. You do have to tune these with a wideband. That's super important. Uh, and the gist of a wideband, in case you don't know, is that it's like an O2 sensor, but it's able to detect a much broader range of air to fuel mixtures. So you're able to see if you're actually hitting the equivalency ratio that you want. Does that make sense? O2 sensor, the regular basic ones are only able to see like very like tiny changes within the system because that's typically what you would expect as an engine gets older. It would maybe use a little too much gas and then it would just dial it back just a little bit to get the sensors in the sweet spot, and it would learn from that. Just to that. With the wideband, if you do a huge cam change, you need like a fuckload more gas, and then you're gonna need to grab a wideband and actually tune these variables here. Uh, yeah, if you're doing like an engine swap, there's a lot more options you're gonna have to change. Let's say if you're going from a 5.3 to a 6.0, uh, typically you can compare those two configuration files and then just input the value data. But let's say you have a 6.0 from a truck and you put it in a Camaro or something fucking crazy and you have a different intake, then you have an issue. Typically, let's say if you do a swap um, into another car, but you keep the same intake manifold. On these Gen 3s, they're typically like plastic. You can buy the aluminum ones, the real expensive ones, but typically they're plastic. You don't typically have to tune the map if you keep everything stock. But if you change the pipe that leads to the intake manifold, then you do have to tune the MAF, which luckily is very quick and very easy. That's typically the first thing that people do is tune the MAF because it's a super linear chart, and as we said, it's just measuring how fast that resistor is cooling. It's probably the most simplest one there. Some people do run MAF only because it's super easy. They just delete their MAP sensor. and there are some special code modifications that you can do. I know HV Tuners has these special functions where you can, tell your computer, oh, I only want map only, like right here, or I only want math only, stuff like that. What else? For the basics. And this is all on the spot, by the way. So sorry for me thinking. PCM, ECM, map, math. Let's go on to basically how it kind of works. So we have map. I might have mentioned this earlier, but let's just go over it. So we have map and math, right? The gist of both of these sensors is just to calculate how much air gets in. They both do it in two different ways. Map it detects the pressure. Math detects the amount of air that's coming in at this very moment. Does that make sense? And using both these and a couple of other sensors like RPM, what else is used? I think that's really it. RPM. Oh, we could check right now if you want. Let's go ahead and look around real quick. General airflow dynamic. Oh, it's right here. Primary VEs. So volumetric efficiency. This is the one that uses MAP. And it is measured in kPa, which is just a form of measurement of pressure. The gist of this is that the computer literally references these values in here. So let's say you have engine speed, and it's able to sense, how much pressure is in the manifold currently, and it's able to reference this. So let's say we have 55 kPa at 800 RPM. That means 47